So our next speaker is Mr. Jigar Halani. He is the Director for Enterprise Solution Architecture and Engineering at NVIDIA. He brings 2 decades of experience in designing large-scale systems for supercomputing, big data, and AI infrastructure across different industries. Prior to NVIDIA, he led Wipro's HPC and big data practices and received the Best Technical Manager Award from Mr. Azim Premji. He also contributed to national and state level committees on data centers, AI policy, and high performance computing. So please welcome Mr. Jigar Halani.
Let me know if you can hear me. Are we good? Okay, great. Not bad. So that was fascinating to hear you. And I know the challenges that we are talking about it. Being an NVIDIan, this is the mission we have been trying to solve since last 8-10 years. But hope to have some conclusion coming very soon. Can you hear?
And the mechanized loom introduced automation and the advent of factories. And industry was born. The age of electricity. Ampere unraveled electromagnetism. Faraday built the first electric generator. And Maxwell laid the foundations for modern electrical engineering. Siemens and Wheatstone's dynamo, the engine of electricity, bringing machines, trains, factories, and cities to life, electrifying the planet, igniting modern manufacturing. And today, born out of the computing and information age, the fourth industrial revolution, the age of AI, reimagining every part of industry. Across the continent, industrial AI is taking hold. From design to engineering, you're blazing new trails toward understanding and reinvention. You brought the physical world into the virtual to plan and optimize the world's modern factories. You're building the next frontier, where everything that moves is robotic. Every car, an intelligent autonomous agent, and a new collaborative workforce to help close the global labor shortage gap. Developers across the continent are building every type of robot, teaching them new skills in digital twin worlds and robot gyms, preparing them to work alongside us in our factories, warehouses, the operating room, and at home. The fourth industrial revolution is here, right where the first began.
Okay. Good afternoon, everyone. We need a tea break. Good afternoon, everyone. Okay, thank you. I know I'm in between tea and you. 3 sessions are done, and I have a less time. I'll try my best to make it exactly 20 minutes or maybe less. So please give me attention so that we can do it within the stipulated time. Of course, the theme of the conference, as usual, every year has been science and AI and the fusion of two. So I've tried my best to keep it in that direction and not go into the pure play AI stuff that NVIDIA is extremely well known to it. But I want to first establish that we have not forgotten HPC. Okay? If that is the notion, any of the scientific community has it, let me make it very, very clear. Our birth as an enterprise journey immediately after professional graphics was the scientific computing world, right? And we don't forget our kids. We always remember them, who has given us the food specially, right, to survive and thrive and build that community, who has then helped to then next achieve the next target of AI, again, done by the scientific world, from a computer science world, doesn't matter which stream it explodes, right? Who knew that the first breakthrough will come from computer science while we started our journey with bio, actually, right? And being computer science, we resonated that very fast. We understood that probably the most, and we betted on it the highest, right? And thereby, FP64 is not going anywhere. Prima facie. I wanted to make sure that we established this pretty well in this event. Followed by that, the stack is also not going away, right? So whatever we have been talking for so many years to the scientific computing world is continue to thrive. In fact, CUDA 13.2. 2.0 came out 5 days back, and we have introduced a completely new type of programming methodologies on tiling based, right? That's going to change the whole new pattern in which the programming has been happening it. I believe cuBLAS is giving now 3x more performance on the same GPU. So I would encourage all of you to go back and look at towards it and upgrade your CUDA version as well. Starting from there to the entire gamut of AI world that we anyway talk about it, and that world is very, very large for us, right? Unlike supercomputing, which was very narrow focused because it was science only, AI has just exploded, and we just saw the use cases. And I think yesterday also you guys have spoken about it a lot. So I'll not go into a detailing of that. But that portfolio for us is 900 SDKs in library today, completely open source, right? And continue to thrive it, right? And I'll give some more statistics as I go in my presentation. Very quickly, moving on. Some libraries which are extremely popular in the country today, and what are thriving the scientific world as well. I thought of just mentioning them, without fail. So, just digest them. Maybe you want to click a photo and, go through them as you go along in the, your, tomorrow onwards journey at your respective places. Read about them. I'm sure you'll get encouraged to use them in your day-to-day life as well. These are some of the most popular that are happening not just in globally, but also in the country as well as we speak. Okay. While we have 900 of them, I've just picked up few of them to show it to you. Let's go a little bit detailing into it, right? So regardless to say that Moore's law has come to a plateau, right? And the accelerated computing is just exploding. Within that, the scale in and scale out is also now getting absolute, thumbs up from every industry to have their workloads to be scaled out. AI is just in the next journey of leapfrog. And from the time this leapfrog has taken place, science has also not left behind, right? And if I have to give you some statistics from some of the scientific computing world, this is how it looks like. So I think this is chemistry, if I'm not wrong, right? NAMD. And look at the explosion from 2012 onwards, maybe, and then 2020 when some of the good papers came out, and then the explosion that has taken place. And of course, generative AI onwards, agentic AI onwards, the numbers are just bloating it out. This is a little bit old dated chart as well, right? This is slightly better one till 2024. Again, similar scenarios. If I have to talk about it, I think 2018 when this, this industry saw the next revolution that was adopting AI and stuff. And of course, COVID added a lot of stuff as well to it, which then has exploded. Again, this is all happening not just on accelerated computing, but tons of things that is happening on AI ML as well, essentially, right? And last but not least, which is the the weather, the most favorite for all of us, being our GDP with so much of dependency with people that we have, about what we claim it as 25 crore farmers today are dependent on this one particular parameter at scale. As we move along, the complexity level of each of these things, that is having to have more smaller version horizons of grid size, that we call it as kilometer by kilometer or maybe less than that, is being expected now to be given as responses to the stuff, right? So I think WHO and Government of India has a very good initiative called Vistar, right? And the first experiment is taking place at Maharashtra, so they call it as Mahavistar, right? Where now, I think the launch date was yesterday or day before. You could talk to the a telephonic number, which is a toll-free number, as a farmer in Marathi and Hindi and English, 3 languages to begin with. It will support now more languages because language is no more a barrier thanks to this Bhashini, thanks to all these models with large language models being in place and stuff. If I want to talk and ask a question about, I want to start the farming for cotton and in Marathi, all in Marathi. What all do I need? What's the journey look to be? It will then set up the automatic reminders to you with your phone number in play, keep calling you when to put water, when to give fertilizer, when to give what is the weather pattern looking like. Hey, you can stop giving water in 2 days. There is a rain prediction, so you will save some on water. Everything is going to get automated for the farmers in their local language. It will be available on 3 platforms, that is SMS, WhatsApp, and over an automated call, like how we all get an automated call from these insurance companies and so on and so forth. No offense to them, for the right reasons, because they need to remind us that the renewal is coming in. Same way, the farmers will also now get these reminders because they inquired about having cotton to be done in their farming land that they have it. All they have to give it is very basic information, right? The phone number, which anyway they're calling it from, the name, so that when the call happens, they call it up. How is the land parcel looking like, an acre, 2 acre, what it is, which location you're growing in, so that you know the weather pattern and stuff, which jilla, which taluka and stuff. Basic information like this, and what all schemes of government of India and government of Maharashtra that you're trying to consume it today. It will also recommend you what are the new government schemes that has come up that they can take advantage of, right? So I hope we are such nice people with education in place. He was able to show us what all schemes he has it, but farmers doesn't have such kind of access with conferences that are taking place around them, right? All they get this is via SMS or a WhatsApp, or if somebody tells him next door in his ears that this is a scheme I have availed, why don't you also avail it? Now government will reach them via phones, right? This is all happening. Thereby, climate, material, all these things, chemistry becomes extremely, extremely important, right? We need to leapfrog as a country. That's what the statement I heard. And that's what every other person is talking about it. Fundamental layer is science. And if AI can help to accelerate this journey, every time, and it's been 20 years now, I work with the scientific community, being a HPC guy. Every time I hear the story that, you know what, we have the best scientists, but we don't have infrastructure. It's like having a Mercedes, but not having a road, right? AI is the only technology that can help you to bridge this gap of not having infrastructure or having a less infrastructure. Trust me, right? Because we could now use lower precisions, a lot of pre-trained models are available. You just need to, fine-tune it with your data sets if that is the first starting point that you want to have it, and you can begin your journey from there essentially. And I'll take some of the examples in that journey. Now, these things looks pretty good, from the individual vertical perspective of what they want to achieve. But guess what? Each of them have division or integration or, amalgamation of any of these 5 technology that we are trying to talk about it, right? So we could think of it as HPC or AI, which is simulation and AI. We could think of it as having a, digital twin to be done. A lot of things these days happens on the edge or an end customer place where the experiments are taking place. And finally, somewhere towards the future side of the story as well, that quantum is also going to get impacted because we need, again, more compute at a lesser price, at a lesser cost. Same as how AI has done against HPC, quantum will do the same probably with AI and HPC as well, right? So it has an intersection of all these 5 things. But guess what? Today, all these 5 things are accelerated by generative AI and agentic AI, right? And there is zero debate to it. The world has time and again proven it, not just in the computer world problems that IT people talk about it, but definitely in the scientific world as well. And I'll touch upon that point when I give my examples. And that needs a very supersonic platform that gives you a interconnectivity between all of these 5 platforms that we are trying to talk about it, right? And I'm super proud that the investments that NVIDIA has done it last 20 plus years in building these libraries to have these integrations going among each one of them, from simulations to AI to digital twins to edge to then now quantum integration as well, is paying off pretty well. And thereby it makes that much life easier for you as developers. And I'll pause there with this 1 or 2 marketing slides that I had, right? And I'm sure you guys are well aware of it. If not, then please go and read about them as well. It will help you make your life easy. Let's take a few examples, and I'll pause then after my presentation as well, right? So what's going on in the scientific world? In the computer world, we are talking about co-pilots, agents. In the scientific world, we are talking about AI, AI scientific agents, right? Co-scientist, how we call it as. And this term is well coined now, and within the GCCs of the country that we see in India, all of them have now a co-scientist working with them. In fact, don't get surprised if you're following some of the companies, they've started to now make their results of quarterly announcements by saying that so many digital co-scientists onboarded this quarter and thereby saving of cost is so much and bottom line has improved so much, so we give back this much to the investors. Right? These statements are becoming very common. Please go back and study some of the companies that you wish to join or already are working on it or are competitions. These statements are becoming extremely, extremely common. NVIDIA is one of them, by the way. Right? And I'll take that example as well, what we are trying to do. My favorite among all these things is on the material discovery, very important as a nation to us, and that will open up a lot of frontiers that we are trying to talk about it. And of course, the coding assistants that we are trying to talk about it. I think this is becoming extremely easy in terms of learning coding now, right? Because coding assistants are available. My humble submission to all of you, you might be from a different background, may not be able to catch up with the coding work so fast, or you might have a code base which are of legacy written by your seniors, your other professors, combination of your department put together, and that's the one code on which you must be thriving it. You want to leapfrog it now, you need to use copilots on coding as well. Use Cursor, use Lovable, Microsoft Copilots are also available. There are many options which are there. Even Indians have developed a lot of copilots on coding side as well. It's helping every single industry we are talking about it, right? From chemistry to bio to weather. I mean, in India, weather forecasting department today use copilots for writing their codes on the CFD model that they have it. We are also trying to help them, right, in adopting this essentially. So it's no more related to just one industry called IT and services. It is very well touching the scientific world as well, and you should be using it. If you're using MATLAB, even they have it now copilots around them essentially, right? Quick one on some of the examples, and I'll just rattle them out. Let's chat over coffee. I know it's a time for break, so I'll not take much of the time, but chemistry, I think we are sitting in a chemistry department. I thought of putting that as a first example, right? And then I'll talk about my own industry, which is, chip designing, right? But again, the co-scientist that we are trying to talk about it is now bringing down the times to months. And there are ample number of examples that are, there, in the market. So again, the same chart, what I showed it to you guys before, but look at the number of papers which are coming. And these are just 2024, if I'm not mistaken. I still don't have a data about 2025. And looking at this scale things happening around it, we started our own initiative on chemistry as well. And we came up with something known as Alchemy, right? That's the product name that we have given it. It's a platform where we are, amalgamating all the, models that are getting trained in the open source world. We ourselves have, taken up a charter of collecting a lot of, data sets around chemistry and other things. We are funding this across the globe for people to generate the right sort of data and synthetic data as well, collecting that data, putting it together, building our own models and making it open source so that you can use it, okay? So is the case with the chip designing world as well. This was our first initiative globally 2 years back when the breakthrough of Transformer to ChatGPT took place, right? And we said that we want to build something known as ChipNemo for building our own chips, right? So today we have 33 years of data of every chip generation that NVIDIA has built. Till the date, all of that data, all the pipelines have been put into one model, and that model is hosted out of our own premises to give it back to our engineers and to two of our collaborators who are the builders of our products, which is TSMC and Samsung essentially, right? So we buy from them, we make them to build our chips as well. We don't manufacture. Using this, today, the amount of VLSI acceleration that we are able to do is unprecedented. And I'll say it only in one line, that you would now know that we have product every 1 year getting changed. Right? So you can correlate a lot of things that I'm trying to talk about it. I can't talk beyond that, right? But not just this, but the number of codes we are able to write for our softwares on the newer chips, even before they get manufactured, is far more higher. All 900 libraries can be now simulated on a new hardware, which is not even taped out or, or not even getting manufactured yet. But we know this is the fundamental that we are going behind it. Its simulations are taking place on that in the computer itself, and the new codes are getting written even before the product is getting into a market. So we are battle ready for software and hardware both. Make sense? Right? And if you say that no, I don't have access to what NVIDIA is talking about it because it's very proprietary to NVIDIA. Yes, it is proprietary because that's what we built it. I'm sure India is no more less. India is building its own through ANRF, a lot of AI for Science project. I have myself worked with a couple of proposals where chip-related stuffs and other scientific-related work that is going to get submitted. It's already been submitted over there. But if you're using any of these, software chain from any of these vendors, we have worked with them to accelerate each and every pipelines of what chip designing is looking today, right? Something similar to the CFD world as well, right? So how we call it as physics world, right? And the newer generation of the model that we call it as, this is a frontier model. We announced it during supercomputing, that is last month only. We call it as Apollo. And I have a small video to show it to you. How does the simulation look like? And once the simulation is done, I go back to my presenter when I entered in, how do you deploy this at the edge with the lowest number of GPU so that you can get the highest throughput and results can be given to the engineer much faster, essentially.
For biomedical. Here at Supercomputing, actually today, we're announcing another family of models, which we call Apollo.
How do I get the full screen shared? Okay, welcome back. Am I audible? Yes. 3 slides left, guys. Be patient. Thank you. And sorry for all the glitches. We figured it out. At least the issue was laptop and not the system. So that much I can tell you, engineers did its job actually. Now let the laptop team take care of it in NVIDIA, right? 3 slides, and I'm skipping that video, but I'll encourage you to go through the supercomputing keynote that NVIDIA did it. I think at 22 minutes, the video for CFD is playing in that we have run it, which is the Apollo model that I was talking about it, and what breakthrough it is trying to do, and inferencing cost, how it's coming down from 9 hours to maybe about 5 minutes. Is what we have shown it just on one RTX card on a workstation which was running in essentially, right? This is a use cases on edge, and I'll be pretty quick because we are really running short of time. Lot of scientific world is trying to use this, starting from satellites to SKA project, to laser systems and so on and so forth. Edge is becoming extremely vital in terms of what its requirements are, and to be very honest, more than anything else, data collection at the edge which is taking place and just discarding the not required data itself is becoming the biggest use case. Then processing it on the edge, right? So if somebody says that let's optimize the power and performance and this and that and all, I would say, guys, go back to your fundamentals, check what the industry need is. And industry need is when a petabyte data or a gigabyte data is coming in every second, you first want to make sure that only right data is what you're trying to save, right? And what is not needed, you are just trying to discard. If AI can do this much in every places where edge is taking place, itself is a big boon that we are trying to talk about it, right? And then, of course, goes back to the story of how can I process the data and how can I make the decision at the edge itself, as a storyline that everybody talks about it. Okay, the last slide, and then a small video. So many of the people asked me during the tea break as well, where are the places where I can go and refer to the documents and details about the latest and greatest that is happening. 4 domains I could think of it that I put it across over there in physics, bio, in weather, and the language model itself, because that's the need of requirement for most of the people. I've put that across, but there are many such links for each vertical that you can think of it, from chip to edge to chemistry to whatnot, and it's there on NVIDIA website. You should be able to go through them. Last video, but I feel it's worth watching, and then I'll end my presentation.
For decades, fusion energy, the process that powers the sun, has been one of science's greatest opportunities. Cracking it would give us a safe, clean, and virtually unlimited source of power. Controlling plasma hotter than the sun's core means solving physics so complex that even the fastest supercomputers struggle to simulate it. At the forefront of this effort, General Atomics researchers and international partners at the D3D National Fusion Facility are using AI to push fusion research forward. The team is building a fully interactive digital twin of the D3D tokamak inside NVIDIA Omniverse. It fuses sensor data, physics simulations, engineering, and AI models, creating a virtual reactor that can quickly inform decisions. Key controls can be explored in the digital twin to refine the science before running real experiments. These surrogate models, trained on decades of real-world datasets and running on NVIDIA GPUs, deliver accurate predictions at unprecedented speed. This is a platform to optimize reactor designs, accelerate commercial fusion, and make the sun's power programmable.
So the true fusion of 5 things that I was trying to talk about it. With that, let me take a pause. Thank you so much for your patience. And good we had a break as well. I'll not take any questions right now. I think I have answered enough at the tea time. But happy to take more questions offline as well. Plus, we have a workshop in the second half. Two of my best colleagues are going to be here who have been doing a lot of AI for science projects in the country. They'll be happy to answer any more questions that you have it. Okay, I'll take a pause. Thank you so much.
Thank you so much.
Thank you.
Small
Thank you. Thank you so much, Professor. Thanks for calling.